Okay. So I want to talk about bending space. I think there's a lot of, everybody's heard about space being warped or, different possible connectivity to the universe, all kinds of stuff like this. I think there's at least a group of astronomers and cosmologists who believe we may be near to actually being able to detect the sort of long-range structure of the universe. But I think there are a lot of, I think it's hard for many ordinary people to get a sense of, what it would mean. I mean, how is it possible for space to have some kind of geometry other than just plain old space? We can talk about, you look over there a long way, and maybe if you go far enough in this direction long enough, if you live several billion years, maybe you arrive back where you started. We can talk about that, but it's sometimes hard to believe that. Anyway, I want to try to give a sort of a little mental image, a sort of mental scenario of how you can think of space being bent, how you can think of space bending in sort of more ordinary terms. So imagine you're walking along this beautiful surrounding here. You're sort of deep in thought. You're not paying much attention. And you look up, and suddenly you notice you're seeing double. There's two fountains up there. You look over there, you see two fountains, and everything's sort of doubled. There's a line here, a line in your vision where it's doubled. And of course, your immediate reaction, if you see something like this, is you think something's wrong with your eyes or your brain. You're wired wrong. But now, so there's this line in space where you see double along it, but you turn your head and the line stays where it is in space. It doesn't, it doesn't move with your head. You walk over here and you notice, the doubling just takes place along that line. So pretty soon you're convinced it's not you. It's really a phenomenon in space. Space is somehow deformed from how you imagined it. What happened? It wrapped around. Okay. We'll see if we get back to where we are. Space has deformed, and there's a dislocation along a vertical line about 20 yards away. Now, this word deformed, I don't like it very much. There's too much of this value judgment placed on stuff like this. So let's just say it's reformed. It's changed. It's not worse. It's not better. It's just reformed. And I guess it's not a dislocation. It's a relocation. It's sort of bent along this line. Well, you think about it a little bit, being scientifically inclined. You want an explanation. And the obvious explanation is refraction. It's a very familiar phenomenon in different ways, using lenses and stuff. But you can imagine that in some way light travels more slowly near this singular line, near this axis, than it does elsewhere. And so the fastest way for light to get from here to your eye is to sort of go around this obstacle. And this is a phenomenon, this bending of light, well, it happens when light travels through water or glass and so forth. It also happens on a large scale caused by gravity. We see gravitational lenses in the universe on a very large scale. Usually a point source, not a line. Anyway, when you look past this line, what you see is your friend over here. You see doubled. Now, you can imagine. Once you allow this thought, I hope you can imagine. The geometry of the universe is somehow bent a little bit along this axis. You see double. It's not very much. But once you allow that possibility, you can imagine. Maybe there's some physical process. This is really a mental process. It's not about physics. It's about reforming your mind so you can imagine how space is bent. But you can imagine it, it bends more and more, that the power of this bending gets more and more. You see more and more double. And as you see more and more double, your sort of line of sight whips around this axis this way, whips around this axis this way. And after a while, maybe the bending effect is so strong at this axis that your vision, your line of sight goes clear around the axis and comes back. In fact, this diagram looks exactly like trajectories of high-speed objects in the solar system as they whip around the planet. They're sort of hyperbolics and so forth. Anyway, this is a strong bending, 180-degree bending axis. And when they do this, when they bend exactly 180 degrees, it starts to be that the images that you see on the two sides of the axis are in perfect alignment. And you get some picture like this. I mean, here you are. You see an image of yourself over here. And if you sort of move around, your image moves. You can try to go up and shake hands or sort of put two heads together, and you can probably prove twice as many theorems this way in collaboration. I mean, it's really, you find this is a very like-minded person, though. That it's really just an image of yourself, and it is a little dangerous to get too fascinated with this image. Okay. Okay. Now we can keep bending more and more and more, and you can imagine that light bends so it whips around a number of times around the axis, and so here's a little diagram. You don't need to trace it out in detail, but you can imagine here's the singular axis. Here you are, and you look out this way, and you see this side. You look over this way, and you see the other side. But if you look closer toward the axis, this sort of line of the optical path sort of makes it once around and then arrives back. Even closer, it winds more around. And the diagram of what you see is like this array of well, here it's 7 images all around in a row. In this case, it's called an order 7 axis. And this is just a more severe effect. Oh, I'm sorry. I'm clicking the wrong things. So I won't belabor this too much, but here's an order 4 axis. It's just one person, but you see multiple images because of the way light whips around the axis. So you can come up. You see a singular axis. You can come up. I mean, you're risking something. You don't know you're going to get sucked into this black hole or something, but you can reach out and now shake hands with yourself. They're really grasping like this, but it feels like it's like this. And there's 4 of you. You can dance a little circle around the axis. Okay. Let's go on. Now imagine in the limiting case, you take a very, very large bending angle. So this axis, you start seeing, 7 images, 10 images, 100 images. They make a huge circle. In order to do this without sort of getting crunched, you need this axis to be far away from you. I mean, so imagine you have a singular axis in space where light bends around it, but it moves farther and farther back as this order of bending goes. It's a lot like actually holding 2 mirrors up and watching what happens, but this is not mirrors. This is a different optical effect, just related. And it moves farther back, and in the limit, you can imagine it going infinitely far away, infinitely many images, and you just see again, this. You could think of this. You can't distinguish this from a circle of radius 1,000,000 with 1,000,000 images and just a whole bunch of images lined up in a straight line. So, anyway, I've tried to take you through a little mentally plausible scenario of how you could end up with space that now the geometry of space is such that everything you see repeats. You start here by this tree, and you walk around, and you're back to the same tree, but you've gone only forward. And you can, do it again. And you're back to where you started, but you've only gone east. Okay, so that's a way that you can imagine the world bending. Now, there's a related thing. I mean, you can think of an optical effect around an axis where space kind of shifts. It doesn't just bend, but it can shift. It's a little like an earthquake, a shear effect in an earthquake. And it's easy to, you can make up a kind of shifting of the geometry of space. This actually happens in some sense, and anyway, so what you see is one side of the axis is higher than the other side. Instead of overlapping, it's shifted this way. And as you move around, you always see that, your right on your right it looks higher than on your left. This is just accomplished by having the speed of light depend on direction near the axis. Some effect that gets stronger and stronger near the axis. So this is the picture of if you see a friend across the axis, that's what you see. And now I'm trying to whip ahead a little bit quickly here. Just imagine you combine these two effects. You imagine a line in space where the geometry can change to a kind of singular geometry along that line. And imagine it can both shift and it can bend. So when it bends a lot, you start to see multiple images. You start to see multiple images, and so here's a picture where you have multiple images that they're both sort of wrapped around like a cylinder, but they're also shifted up and down. So this is a sort of picture of the combined effect of how you can bend space. I mean, this is okay. So I want to try to show you pictures of what real live universes what the real life universe might actually look like. And to do that, after a while, the ordinary geometry of Euclidean geometry of space is not adequate to really understand these kind of possible ways that space can be connected. So this is a picture of a plane, of a kind of Euclidean plane, is seen in perspective. I don't have this well animated, but you can see it a little bit. You can see it changing a little bit. Here's an exaggerated perspective. Here's a less exaggerated perspective. But our eyes are such that we learn to interpret a picture like this as if it's a flat plane. This is a plane ruled into. It's divided into fields, and there's some crop rotation system. So two different kinds of crops growing in this checkerboard pattern. Now it turns out that there's other kinds of geometry we're not very familiar with from the real world, but in fact our visual systems are pretty well accommodated to being able to see these kinds of geometry. So in particular, there's a kind of non-Euclidean or hyperbolic geometry that's quite important, really. It has a lot of places, a lot of ways in which it can model different kinds of mathematics. It occurs all over the place. It occurs in number theory. It occurs in geometry. But and this is a picture of the hyperbolic plane or non-Euclidean plane as seen in perspective. And there's not much time now, but if you spending a little more time, you can you can learn to accommodate to really see this kind of geometry. So as I move this, it helps your eyes tune into it a little bit better. But just imagine that all these triangles, they're really equilateral triangles in the hyperbolic plane. The ones around the edge are sloping away. And hyperbolic space well, things recede with distance much quicker than they do in Euclidean space. So, I mean, you can watch this. This is like we're flying over the hyperbolic plane, and those triangles, they get small quickly with distance. And no matter how small they are, they keep receding equally fast with distance. So, so this plane looks as if it's, I mean, the visual image of it is round, unlike a Euclidean plane, which takes up a whole sort of hemisphere of your vision. It takes up a limited space, but it recedes on all its edges. And anyway, this is a picture of the hyperbolic plane. I could switch to this collided tile thing. This is this image we had when we first came. Here's another picture of the another map of the hyperbolic plane. This is not in true perspective, but it's trying to give you a sense of what it is. This is an arrangement of well, if I arrange it like this, these are 7 gons arranged 3 to a vertex in the hyperbolic plane. In the Euclidean plane, we can arrange hexagons 3 to a vertex. In the hyperbolic plane, you can put polygons of any number of sides. I mean, there are many, many arrangements of this sort, because somehow in the hyperbolic plane there's much more room. Anyway, let's go back to here. So this kind of geometry. I mean, this is a picture of a 2-dimensional plane in hyperbolic free space. Now, by looking at hyperbolic geometry in 3-dimensional hyperbolic geometry and bending it along axes, and it turns out you can create almost any kind of topology. So here we can start with, you can imagine, I mean, here are two circles in space that are linked together, and there are ways to create these kind of order n or order infinity reform space, order infinity. I mean, order n and order infinity cone angles along or bending orders axes along knotted curves like this. And it can be done quite efficiently by using computer programs, which I'll just illustrate in a second. So here's the picture of this link. I just clicked the button, and it immediately computed this geometry of the space bent with order infinity bending around each of these axes. So now in this geometry, which we don't see here, but which is computed, if you were to look at this axis, your light rays would wrap arbitrarily many times around these axes. So on both actually the long way and the short way. We can actually see pictures here. So here's a picture of how light looks. I'll try to interpret this in a minute. I mean, this is a picture of something you see within this space with the bent up geometry. So first it's only drawing a finite number of images. I'll draw a few more of these images. I can go to more. I'll draw a little. I'll scale it a little bit, and now let's just stare at this. So if you remember in the original picture, which is here, there's a blue knot and there's a red knot. Now in this picture, of course, I mean the knots have become infinitely far away. They've disappeared from the line of sight. In this picture, they've been replaced by there's a little balloon around each of those, or like an inner tube has been created in there around each of the 2 knots. There's a kind of fat one around the red knot and a kind of thin one around the blue knot. But space has been bent so that the knots are not there anymore. There's order n axes, order infinity axes that have gone off to infinity. And so each of these red things is really only the single red inner tube. You just see multiple images. You can see how it repeats, donk, 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 donk. This is just like those people that you saw repeating in my geometry sketchpad pattern. You see the repeats of the blue one. And, and it's actually not, it seems to me, and to some people anyway, that it's not unlikely that the universe has a pattern, related to one of these. So by using these knots and links, and by doing this, we can do these other kinds of shifts other than the infinite shift by things like typing in numbers here. This tells what I'm making the blue one an order 3 cone axis now, and suddenly we get a picture like this. Or I can do another kind of shift here and got another thing. This picture now is just a gluing diagram for the universe. I mean, I don't have all the possible pictures here of what it would really look. I don't have the picture of what it would really look like with all the repeating images that can be computed sort of readily. And it's not unlikely that using cosmic background radiation, we may be able to actually see some. I mean, in the next few years, we might be able to detect one of these patterns in the real universe. But even whether that's true or not, I mean, the mathematical uses of this are I mean, there are many sort of more down to earth, so to speak, mathematical applications of this. I think I've said enough, so let me just stop and.
I think we'll